Hello, my name is Joel Gonzalez, and I am the product specialist for MegaGen USA. In this particular video, we're going to be analyzing the different aspects of the AnyRidge system. The AnyRidge system is truly a paradigm shift regarding implantology because we're truly taking bone biology, in other words, the different densities of bone, into account, as well as the ridge width and the very unique thread pattern that we will be showing and highlighting a little bit further in the video. And just as a note, you can pause this video at any time to further analyze the words and so forth that's going on in the video itself. So one of the things I'd like to point out is this implant system is truly taking bone biology into account. So what does that mean? We're dealing with your different types of bone. In other words, your type 1, type 2, type 3, and type 4 bone. The anterior mandible is type 1, posterior mandible is type 2, anterior maxilla is type 3, and posterior maxilla is type 4. And you can see the different densities involved. With the AnyRidge system, you're going to note the different types of thread patterns that we utilize to get increased primary stability in the different thread patterns themselves. Let's analyze the traditional implant system itself. You can see the implants as the implant size gets bigger, your drill gets bigger. So what's that really doing? You're taking a lot of valuable bone away. So as you take bone away, you're taking blood circulation away from the area. Thus, you have a lot of different types of cupping. People call it dieback, and so forth regarding different types of ridges, because as the implant size gets bigger, again, you're compromising your crestal bone at the top, therefore decreasing the valuable blood circulation in the area. Again, look how big the final drill gets for an 8mm implant. It's 7.4 millimeters. That's a lot of bone to be taken away. So the AnyRidge is truly a paradigm shift, as our cores are now very consistent, but what's changing is the thread pattern itself. The thread patterns get wider. So this is truly a biologically driven implant. It's a bone level implant, conically sealed, 5-degree Morse taper. It's internally hexed, as well as platform switched. Let's look at the different design concepts for the ideal fixture just in general. If we could draw a blackboard and just have a brainstorming session and go, what could we dream of for the ideal implant? You see thus the crestal bone patterns up top. Every implant that's coming across here, as we analyze them, it's compromising the crestal bone. So the AnyRidge system, with the very unique thread patterns, gets amazing primary stability, but as well as it does not compromise the blood circulation as well as crestal bone at the very crest of your ridge. Let's look at the prosthetics quickly. The S-line prosthetic is very unique because you have an extreme platform switched scenario, but you have a very strong connection. It is a 5-degree Morse taper with, again, an internal hex, so you feel it very, very nicely when the abutment goes into place. But again, with that 5-degree Morse taper, the connection is very, very strong. And the thing to note with all 10 different diameters of implants, as you can see by this picture here, is from 3.5 all the way to 8.0, it utilizes the same prosthetic connection. Which, guess what? What does that mean? That means you're going to have a lot less confusion regarding different prosthetic abutments, what size abutment do you need, what size healing abutment in dealing with your different prosthetics. Now, as you can see again, your different healing abutments come in 4, 5, 6, 7, 8, and 10, all relative to that. Now you can see the different densities of bone. Again, D1, D2, D3, and D4. As the density gets, the number of the density gets higher, like D4, the thread pattern actually gets wider. So you have D1, D2, D3, and D4 again. But you're really dealing only with 3 core sizes. Okay, the 3 core sizes are 2.8. 3.3, and 4.8. Your 3.5 is a 2.8 core, your 4.0 through 5.5 is a 3.3 core, and your 6.0 through 8.0 is your 4.8 core. Note on here the different aspects of the very unique thread design. Again, you have where the blue lead is, the blue little diagram there, that that has an increased lead by 0.4 millimeters circumferentially, so you really get increased stability. Let's note this little video here and really pay attention to the surface area. as the implant gets placed. That's a D1 bone, a 4.0 implant by 10, 170 millimeters squared. 4.5 by 10, D2 bone, 235 millimeters squared. D3 bone, 5 by 10. And note the different densities of bone. As they get softer, it gets more spongy. And D4 bone, 5.5 by 10, is 388 millimeters squared surface area. Again, all utilizing the same prosthetic table and connection, which is very, very nice and very easy for the end user and final clinician. So in this particular series, we're going to be showing two different implants, two different cases actually, shown by the same doctor. And this doctor was placing her very first implant ever. I was assisting her through the whole process, and it really was a smooth process utilizing the implant, the AnyRidge implant design and surgical kit, which makes your life a lot easier. You can note the two spots where we're going to be placing our two implants. And again, we're going to walk you through the whole process here as the video goes on. Important concept: you have your soft bone protocol and your hard bone protocol. Your hard bone protocol, or dense bone protocol, if you will, really deals with utilizing your cortical bone drills. And we'll get into that a little bit further, again, as the video goes on and we actually do the case. Now, one thing to note is the actual drill length is, let's say we're going to be placing a 10 millimeter implant. Your stopper drills are very nice because they're already cut to length, but your actual implant is 1 millimeter shorter than the actual written length of the drill. So a 10 millimeter implant drill, your implant is actually 9 millimeters long to automatically place that implant subcrestally. So we're really going to only be utilizing 3 drills: a 2.0, 2.9, and 3.3, because the 4.0 through 5.5 implants only have a 3.3 core. So that's our main goal. And again, all based upon the density of the bone, because if we have a D1 bone, we would actually try to increase that osteotomy slightly from 3.3 to 3.8. So we'll go over that in just a second as well. So we're going to be only drilling to 3.3 for our implant in this particular case. I cannot stress enough to you the use of the cortical bone drills. The cortical bone drills are specifically for D1 and D2 type bone. You can see the drills going into the cylinders here, marking the bone. But as you need to open up that osteotomy, you simply utilize the cortical bone drill to do that with. Now, at this point in time, we do not have the 7 millimeter length implant available, but that is coming hopefully in the near future. The lengths are 8.5, 10, 11.5, 13, and 15, but 1 millimeter shorter than the actual written length. So an 8.5 millimeter implant is actually 7.5, and so forth and so on. So let's look at the case. Here we show the incision and flap of the particular area where we're going to be utilizing these implants. You can see clearly the nice ridge. We've already debrided the area of granulation tissue. And now we're going to be initializing our drilling process. I like to utilize the 7 millimeter stopper drill first, then take a digital x-ray to actually have a really nice marker of the area. Your 7 millimeter drill is not going to be compromising any anatomical structures, so therefore we can utilize a 7 millimeter stopper drill first, take an x-ray, and then proceed from there. However, you can note the bone in this particular area sloping upwards, and you can see where the stopper drill is not fully seating. So therefore we had to over-prepare the osteotomy and utilize the 11.5 stopper drill to place a 10 millimeter implant to the proper depth that it needs to be. Next, you'll see the 2.9 stopper drill. The 2.9 stopper drill, again, utilizing the 11.5 length, which again, we're only going to be placing the 10 millimeter length implant. But due to the sloping bone, we needed to use an 11.5 drill so that your implant platform will be at proper depth. Stopper drills do come in 7, 8.5, 10, and 11.5 lengths, and they do come in each diameter, which is very nice for the end user. Really look at the handpiece adapter here. You can note the different depth markings on there, and you can see where it engages with the internal hex there, and it also shows the hex indicator for your aligning of the hex itself. The markings on your depth gauges there are 1, 2, 3, 4, and 5. You can note again the hex marking showing you all the time where your hex is so you can place it straight facial. With this particular implant system, you always get phenomenal torquing or initial primary stability with this implant. Typically, it does not seat to depth. It's about 1 to 2 millimeters short of your final depth, and then it typically torques out to 50 Newton centimeters very quickly, and then you will actually place the implant to depth utilizing your ratchet adapter, or what other people call ratchet extension. There you see the ratchet extension in place. And now this is a really nice pathfinder that screws into the implant once your implant is in place. So you can utilize that your pathfinder rather, for a future placement and checking your parallelism at every chance you can. Again, the 2 millimeter stopper drill at what length? 7 millimeter length. Should just note where we are, take an x-ray, and so forth. We're going to proceed with the case. As you can see, there's a 7 millimeter stopper drill nicely in place. You can see the depth of the implant platform with your pathfinder in place. But note the different peaks and valleys of the bone itself. So again, we're going to over-prepare the osteotomy slightly due to the implant length of the adjacent implant being a little bit deeper, so we had to do that with that particular drill. Now here, there's a 3.3 drill, and then your dense cortical bone drill. We did open that up a little bit because we ended up using a 4.5 implant in the posterior based upon that. Now you can see the really nice depth gauge that's built into your drill, which is a really excellent aspect of the particular marking drills, or what we call your longer drills. Your ratchet adapter is in place, again placing that implant to final torque values and proper depth for your platform placements and your proper emergence profile for your future restorations that you're taking into account. There's your tooth pathfinders. Again, just noting the parallelism. I cannot stress to you enough the high torque values that you will achieve with the AnyRidge system. When you're looking at this particular implant, again, it is typical for it not to seat fully. Here you note the single stage procedure that's always typically possible with your AnyRidge implant, simply because of the high torque values or high primary stability reached. Now here you see a really nice molded formed what we call gingival formers, filling abutment in place, really nicely formed around that. Now the very unique thing about your AnyRidge system, again, because it utilizes one prosthetic table or one prosthetic connection, all your different healing abutments are interchangeable. That means you can really control your aesthetics much easier. You can see and note the different healing abutment flares in place in these cases here as they're shown on the x-ray. They do come in 3, 4, 5, 6, and 7 millimeter cuff height in all your different flares of 4, 5, 6, 7, 8, and 10 millimeter diameter or flares. Okay. Now, regarding your different prosthetics as well as your different options, we will be going into that in just a second. Here you can clearly see your platforms at a nice even parallelism, typically 2 to 3 millimeters below your CEJ, your adjacent teeth CEJ. This one's a little bit deeper, again, because of that sloping bone, but we couldn't have one implant at one platform length and then other implant at other platform length. So we definitely placed our implants really nicely. A really good rule by Daniel Buser is as shallow as possible, as deep as necessary. Shallow for biology, deep for aesthetics. You definitely need the deep placement, again, 2 to 3 millimeters below the CEJ of the adjacent teeth to deal with your proper emergence profile. You note the different transfer impression copings here, 4, 5, 6, and 7 millimeter flares. However, once again, one prosthetic connection. So all of those are interchangeable. Same thing with the abutments, as you can see. 4, 5, 6, 7 millimeter flares, but one prosthetic connection with your 5-degree Morse taper and internal hex built into them nicely. Anything that's final as far as the abutment goes utilizes that abutment retrieval tool that you used, that you saw in there, and you will use that to remove any final abutment as that 5-degree Morse taper truly grabs that abutment into place. Note the different prosthetic options that you see. Just as a little measuring device, you can see there was a 5 flare. Now that's a 6 flare to note the different emergence profiles you can deal with. Here you see all the different abutment options that are available: easy post, X-ray easy post, angled abutment, milling abutment, zirconia abutments. One prosthetic table. We do have your PMMA temporary abutments that are very nicely utilizable for immediate prosthetics. The really nice thing about all of our abutments, your final abutments, they come with a lab screw that's thrown in there for free. The lab screw is blue. Your gold screw is your final screw. So you keep that, send your lab screw with the lab, with your case to the lab, and they use that for the lab fabrication portion. One thing I cannot stress enough is I was a dental assistant for 13 years and had to keep stock of many different implant systems. Having one prosthetic table will definitely save you a lot of money and time in dealing with no more small platform, regular platform, wide platform. The video you just saw emphasized the high torque values that you can get with this particular implant. That torqued out immediately at 50 Newton centimeters. You can see the implant is about 2 millimeters high. There's your ratchet adapter into place, placing it to its final depth, and your single stage process that you can utilize because of the high torque values. Nicely molded gingival aspects around the implant. Thank you very much for your time. I really appreciate it. If you have any questions, please give me a call or email me at your convenience. Thanks again.